Hello, and welcome to this presentation, Getting Started with the EVS1000 GPS Configuration. In this presentation, we'll show you how to configure GPS support on Rohde and Schwarz EVS1000 series analyzers. This presentation assumes a basic familiarity with Rohde and Schwarz EVS1000 series analyzers. If you're unfamiliar with the EVS, or if you'd like a review, you might want to watch the presentation Getting Started with the EVS1000 General Overview before continuing with this presentation. Software option K20 enables GPS data to be used with the EVSg1000. No option is required to use GPS on the EVSf or EVSd models. GPS data is used to obtain or derive both location and velocity information, as well as date and time. The EVS1000 is connected to an external GPS receiver using either an RS-232 or USB connection. Although the GPS data can be viewed in real time, the primary use of this data is for logging and data recording. That is, the location and other GPS-derived information can be logged and stored together with measurement results. On the EVSg1000, GPS receivers can be connected to either the front or rear USB connectors, or to the RS-232 connector on the rear panel. The EVS can also accept a PPS, or pulse per second input, via an SMA connector on the rear panel. Pulse per second can be used with all measurement modes, but is particularly important for GBAS measurements. Please see the documentation for information about attaching GPS receivers to other EVS models. GPS receiver configuration is accessed by pressing the Setup Hard key and then selecting GPS. This can also be done via VNC by pressing N and then F8 and F6. There are three basic GPS configuration parameters. The first of these is the baud rate, which must match the baud rate of the GPS receiver. The next is the interface type, RS-232 or USB. Note that there are two USB variants, the standard interface and the U-Blocks interface. And third, the GPS delay may optionally be configured. This parameter can be used to compensate for the time needed to transmit GPS coordinates over a serial interface. Once the receiver has been attached and properly configured, position information should be displayed. Latitude and longitude are displayed in degrees, decibel minutes, and altitude is displayed in meters. Speed is derived from GPS position information and is displayed in both knots and kilometers per hour. In addition to location data, GPS is also used to derive date and time. And lastly, the number of satellites and the type of fix are displayed. Here, the abbreviation DGPS indicates that the information is based on differential GPS measurements. GPS receivers output data in the form of NMEA strings, which are shown at the bottom of the GPS setup screen. Incoming provides a live update of the received strings, and three specific strings are displayed continuously. The GPRMC string, which contains information about speed, track, and magnetic variation. The GPGGA string, which contains information about GPS data accuracy and fixed quality. And the GPGSA string, which contains information about the operating mode, number of satellites used, and the precision of the derived data. These can be helpful in verifying the quality of the GPS information supplied by the receiver. If GPS data is available, it's stored together with measurement results. This allows us to correlate measurement results with certain geographic locations or along certain paths. As mentioned earlier, there can be slight delays in GPS time due to the time it takes to transfer GPS data over a serial link. And, in some cases, synchronizing the GPS data with a pulse per second output is desirable. Higher-end GPS receivers often provide this PPS output signal, which can then be fed into the SMA connector on the back of the EVS. The configured pulse edge direction, rising or falling, must match the GPS receiver settings. Otherwise, there will be no PPS lock and an error message will be displayed. In this presentation, we've covered GPS support, which requires option K20 on the EVSg1000, but is standard on the EVSf and EVSd. Both USB and RS-232-based GPS receivers are supported, and although not strictly mandatory for most applications, the EVS also supports a pulse per second input. Configuration is very straightforward. In addition to GPS interface type, baud rate must also be configured, and a GPS delay is recommended in some cases. Based on the received GPS data, the EVS will derive and display latitude, longitude, altitude, speed, and date/time. This data is stored and recorded by default with all numerical measurement data. This concludes our presentation, Getting Started with the EVS1000 GPS Configuration. If you'd like to learn more about the EVS1000 or other avionics-related topics, please see the links in the video description. Thanks for watching.